So our next speaker is Carol Wilder, a Director of Strategic Planning at Intel in the Data Center Group, specializing in storage. In her current role, she leads a team that defines and drives key business and technology innovations for the storage group. Thank you.
Thank you. Let me put on this microphone thing. Okay, can everyone hear me?
Test. Yeah.
Okay, awesome. So I should say that true to Intel form, if you know Intel, I got reorged 2 days before my sabbatical. And I actually now have systems, software, and segments for strategic planning. So storage is part of that, but I actually own parts of AI, the memory subsystems, as well as understanding all of the segments that Intel services. So it's been quite, since I came back from sabbatical, it's been drinking from the fire hose. So that's been pretty interesting. So let's see, let's go on. You now have legally notified. Does everyone feel good about that? So what are the mega trends? Whoops, let's not fall off the stage. I'm going to be down here. I don't know. What's better? Up here? Okay, I'll do it up here. When you look at the mega trends, we look at major things that are pushing storage forward. And when you look at that, cloud, and I want to make sure that it's not just the Super 7. We have a major shift going on between what's going to be on-prem, what's going to be in the cloud, and how to blend all of that data to know where things are and what's the best economics for that. So that's when we talk about cloud economics. Clearly, AI, artificial intelligence. Currently, when you talk to an Intel person, you'll look at AI as machine learning or deep learning. I see it as natural language processing, natural language understanding, text processing, a whole wide range of analytics activities. That's also driving huge amounts of data, particularly, for example, if you know machine learning training. The amount of data that you have to have close to a compute node in order to do that machine learning training is enormous. So that also is stressing out the storage. And then, of course, we have the looming 5G. So we're all looking forward to the Korea Olympics. And 5G is probably going to make its entry there. So you've got all of these things coming together with all of the different devices, with obviously automatic driving, connecting cars, insights for systems so that companies can make decisions faster based on analytics, and then all of a sudden the cloud, with giving a lot more degrees of freedom for businesses to architect what are the best economic price points for their services. We see also this combustion of a traditional economy, so on-prem, storage, scale up, IT, with the digital economy. So we have a bunch of digital fusion ideas, or a blending of traditional and digital businesses. And when you look at it, smart agriculture, so putting sensors in the ground and knowing what are the plants getting and what's the best optimal conditions to grow crops. We're looking at artificial intelligence, wearables in an industrial sense. You have warehousing, autonomous cars, and then smart retail. I was talking to someone about 6 months ago, and in one retail store, they only keep one of everything, and they have them RFID tagged so they know exactly where that stock is, and then they can blend it up and know at night what they have to replenish immediately. So they're holding stock in the store in the smallest amount level that they need in order to maximize the profit in that particular store or the series of stores. So we're seeing this bricks and mortar plus AI plus everything else. And what does that think? The data has to be stored somewhere. It's an asset. It's now not just dumping and saying, okay, we have that. It's being used actively all the time. So data is the new oil. I think you've seen that on some of the taglines that Intel has come out with. I personally have a love-hate relationship with that thing. I was telling someone earlier today, it was the name of a report that I heavily contributed to in 2012 to convince Intel to be more of a data company. Well, it's 2017 and we are. So it took about 5 years. Intelligence is the new engine, but storage will be the fuel tank. And we really need to look at, rather than storage being a tax that everyone has to drag along with them, that it's a huge asset. And the intelligence and the insights, and the faster that you can go with that data, then basically you have a much faster virtuous cycle for businesses. But, you know, as with every transformative time which we're in, there are pushes and pulls. So when you look at it, we're looking at performance significantly going up. And we ourselves are driving that with the Optane drives, for example. And I think everybody's seen the press around that. Storage needs and durability. Security. This is one that I think everyone inherently knows has to be dealt with, but how do you deal with this? This is one I just read Diane Green's transcript. She did something at the City Technology Convention, and her first points that she talked about, so Diane Green is head of Google Cloud, I think most people know, but her first thing that she talked about was security. I was very surprised. I would have thought it would have been in their service sector, but the first comment she made was on security. Data throughput and system efficiency. And so these are the things that are going up. We have to be able to maximize for that. But on the same thing, power consumption, latency, reprovisioning time, and then obviously the total cost of ownership. And I think everybody probably in this room has seen total cost of ownership models. They're all different. We've tried at Intel to put those together, and we have these complex things that we have that are run not anymore on Excel spreadsheets. We have them running on some of our databases and some intelligent systems that we put in place, and we still don't always get it right. And we have a lot of data that comes into those total cost of ownership models, and we're looking at it going, well, wait a minute, we haven't thought about these cases and that cases, and every customer is different. And so when I talk about storage, it took me a while to get everybody in Intel to understand storage isn't about the disk. It's not about the media. Storage is about the strategy of putting compute and data together at the right economic point for that particular service, and then when it's no longer needed to be processed, then moving that storage off to the right economic point for that particular service. And making sure that we have that blend and know what those economic points are and what the technologies that could achieve those economic points are. And this points out this going up and going down. We're seeing this all over the place. Not just in cloud. We're seeing this obviously big time in enterprise. And then there's the whole hybrid cloud. How do I handle that? And we're seeing these requirements change in a big way. But we need to get smarter. We now have all of these data pools, data lakes. And so if we start with the enterprise and we look at that, we still have the traditional scale-up, scale-out models. But moving over, we have orchestration over to the cloud. And how do I orchestrate all of the different resource pooling? What are the right, where the data is? Where does it have to be? But then, Internet of Things, all right? Looking at this and trying to figure out all those consumer devices. What am I going to do with those devices? What do I do with that data? We have the fog, which is that loose connection between what the enterprise is looking at and then all the Internet of Things. How are we going to blend all this together to get one cohesive view? And it's very, very complicated. And the only way to do this is to basically start creating intelligence and start creating self-tuning networks or self-tuning storage networks that basically can read and basically know how to move the data back and forth, or at least let the users or let the administrators know you're not doing the best thing for the economics that you've set. And we need to get smarter. And there's starting to be some examples of this. Clearly, I think a lot of the cloud Super 7 have figured out for their own particular needs how to be able to measure and know and tune their networks, their storage, and their compute in order to be able to get the best out of what they need and be able to communicate the requirements. But those are very specific workloads, very specific markets. I think for the broader generation, or the broader, especially with Internet of Things, I think we're going to have to start to create new paradigms and new use cases and new ways of thinking in order to get that done. So what we see is in this hyper-connected world, which obviously augmenting that with Internet of Things, we have a deluge of data. We've got 5G, which is going to put more and more data on networks, particularly like I've been talking a lot with people, not on automatic driving, but a lot about connected car, which is going to be a huge driver of data centers as we move forward. The data that they need to connect to, they need to collect, but then act upon in order to have a connected car is immense. And 5G will help with that in terms of the latencies between the data center down to a moving car. Cloud processing and analytics, and then all the connected devices. If you have phones, you have watches, you have tablets, you have all of the traditional, and then you have the non-traditional. Echo, Google Home, all of the different smart home devices. And then you have eventually smart cities. So all of that is going to contribute to all the connected devices. We do have a software infrastructure that we started, I'd say, about 3-4 years ago. We've worked closely with SNIA on called Intel Rack Scale Design. And we look at it as there's an orchestration software, and then we slice it up and look at compute pools, storage pools, hot, warm, cold, accelerator pools, and then FPGAs for other than accelerator. And we need to start to think about a revolutionary sort of way to look at all of these different architectures to try to make sense of the world and try to aggregate and know how to help along with particularly storage to get the best economics and the best performance out. Does that make sense? Okay. So just as a plug for rack scale, if you look at traditional server design, all right, you see compute, you'll see storage, and then you see the memory subsystem. So it's generally a fixed configuration with varying degrees of things. When we looked at how we would be able to look at it in a different way, we looked at orchestration layers to do disaggregated, composable resources and pooling as needed. And there's software infrastructure in order to take, and I believe it's open source, that you can take advantage of the compute, the storage, and the accelerator nodes in order to have a better way of managing those for the best economics for the workloads. And then from there, for a workload, you take a slice of essentially what you need for that particular workload. It could be more compute, more storage. It could be more accelerator or more storage with that. And basically look at how to compose it differently in order to meet the needs of workloads and re-provision quickly in order to go look at a certain workload. So this is something that we have been working on for, like I said, 3 or 4 years. It's by no means the perfect answer, but it's a way to look at it that may help in order to maximize profits and efficiency. So when we looked at rack scale manageability, we had to go through several things. Resource discovery, what's available in the node or in the pod that can be used. System composability, how would you compose that for a certain workload? Resource telemetry, so how is it performing? What's the measurements of that performance? And how do we tune that performance to a certain workload? And then obviously manage the resource and the system so that we could make sure that it's optimally performing. So we went from orchestration, we've obviously supported VMware, OpenStack, and then we have custom configurations. We had Pod Manager, which helps with discovery, boot, configuration, and telemetry. And then we have worked on a rack management module, RMM, and then a pooled system management engine. From there, you have all of the hardware resources through some firmware APIs that allow you to hook in compute resources, storage resources, and accelerator resources in order to help with the most flexible architecture for implementation. And all of this software, we provide the reference code, and then it's up to the particular end user to be able to tailor it to what your specific needs are. And we believe that in this way, we're able to, again, like I said before, maximize efficiency and be able to maximize flexibility for customers based upon the economics, the workload, and then any future enhancements that you're looking for. So I wouldn't be Intel unless I talked about hardware. When we look at it, there's 3 slices in the data center group that we commonly refer to. So I'll start with the easy one, which is compute. So obviously, we're a big provider of compute, from scalable processors, so our Xeon FPGAs, accelerators, and then there is a technology, it's called Quick Assist technology. It's basically encryption and compression that is in line for customers. On the comm side, we provide networking fabric, so east to west and north to south connectivity, silicon photonics, Ethernet, and network function virtualization. But in the storage area, we have a number of things that we have announced or that we're working on through open standards. When we look at it, 3D XPoint, I think the last, I walked in and the slide said, "Thank you for Optane" on the last slide, which I was like, and I sort of looked, I said, "Is somebody from Optane here?" I didn't know that. But we have Optane. And then we have, obviously, 3D NAND that we're ramping on. SSD and DIMMs, EDSFF, which is the small form factor open, I forget where it's under, but basically it's this idea of having a connector on a backplane, obviously, that has a wider range of bandwidth for future systems that are going to be built. So it can run well up over, I believe definitely over 32 gigabits per second, but way up over that as well. So it gives the forward-looking flexibility in the latencies that the cloud and others are looking for in that technology. And I know Amber Huffman is driving that group. NVMe, RSD rack scale design storage pooling. And then there is a feature that we have released with the Skylake processors called VMD, Volume Management Device. So with all these advances over the last 2 to 3 years that we've seen coming out of Intel and others, we believe that this coming through allowing storage to be looked at more as a systems level versus as just the disk or just the NAND, All of this plays in for the scalability of storage services at the end user. You can't essentially put in a 3D crosspoint technology, but then use 10 gigabit 10 gigabit networking fabrics. That would be a waste. You have this low latency drive with a high latency connect. So you need to scale things based upon what the needs are of the business. And we've invested in each one of these areas to make sure that at the right price point and at the right performance, that we have the right solutions being pulled together. But you can't just have software. You have to have, you can't have just hardware. You have to have software infrastructures that will also scale and provide solutions for customers. Much of what we do open source in order to enable not just Intel, but also some of our key partners. When we look at on the compute side, we've recently come out with AVX 512, which has helped enormously in the AI area. And that came out with Skylake, and you can read about it online. We've made our FPGA SDKs for OpenCL. We have a math kernel library, MKL, for AI as well. We have a data analytics acceleration library, BigDL. We're working on Neon and deep learning optimized frameworks through our Nirvana acquisition that just happened earlier this year. And we have Cofluent, Studio, and Hyperscan. When we look on the other side in comms, I think there's two that are kind of sisters of one another, or brothers, whichever way, which is the data plane development kit, as well as the software performance development kit, so SPDK and DPDK. These, yes, while they were kicked off by Intel, they are open source and they are not governed by Intel at this point. And we're looking at this as a community activity that everybody can partake in. So if you want to go look at the GitHub for that, feel free. We have many in fact, our competitors that use SPDK and DPDK. We have network functional virtualization and single root I/O virtualization in the comm space. And then in the storage space, we're continuing to invest in the ISA-L, which is the Intelligent Storage Acceleration. It's a hardware, it's in the CPU, and we continue to invest and provide that open source as well to the industry. And I've heard nothing but great things. In fact, last year when I spoke at this conference, somebody basically stood up and said, if you're not using that, you're crazy. It's one of the best things. So check it out. Persistent memory over fabrics, we're a huge supporter of that within SNIA. I talked about SPDK. We've got cache acceleration software for storage, and we spend a lot of time on the AES-NI, so advanced encryption standards and new instructions on every CPU every CPU generation. We invest in that as well. So how can storage be smarter? Last year, I had a very similar slide, if you were here. And we look at the modernization of storage. Clearly, we're seeing right now, it's still largely disks. We know that. But we see this huge, because the economics of SSDs are coming up and the performance is being needed by a lot of services. You see this hard disk drive to solid state transition really happening now. Storage primitives are needed for that. We also have seen the automation and orchestration, so unifying a lot of the cloud and the enterprise storage systems. So more and more, obviously last year I have a huge amount of conversations on how to implement scale-out storage. How do I implement this to gain the best economics and the best flexibility in my storage system? So scale out, hyperconverged, software-defined storage, all of these are things that I think are well known. But as we move over, we're looking at intelligent data management. And this is the extra layer that I think everyone else is really grappling with, is how do you deal with hybrid cloud? What does hybrid cloud mean to you? We see people who are pushing and pulling in and out of the public cloud. I think Nike just announced that they're pulling out of AWS and going back to their own data centers. We've seen Netflix has a bifurcated model. So their customer data is with AWS, but their CDN, their content data network, is with Netflix. So we see this going on all the time. There's this push-pull where the economics for public cloud no longer make sense, and they go to a hybrid cloud, or they pull back into their own data centers. What do they need for that? We continue to work with those companies to understand what that data looks like. Machine learning and deep learning. There isn't one customer I don't go visit where they want an AI roadmap. Tell me what your AI roadmap is. And honestly, there's no one AI roadmap. It depends what you're maximizing for AI. Are you maximizing for this very deep training? Are you maximizing for an inference loop? Are you maximizing for just gaining some insights in line? What is it that you're maximizing for? Because that solution for AI looks very, very different based upon the needs for that. Predictive analytics. One of the big things is cars. Think about a car as basically a server on wheels. That's what it is. And that car has a predictive engine at the beginning looking at all the sensors and saying, that's a ball. You can probably run over the ball and you'll be okay. Oh, that's a child. Don't run over the child in a horrible way. But you're looking at that prediction and very quickly in latency having to have the car make a judgment. It's a server on wheels, and they're pumping some data up into the cloud, but the latency from going to the car up to the cloud, it's not going to be enough to avoid the ball or the child. And so it's basically a server on wheels, and predictive analytics is the engine that basically runs through that. Self-diagnostics. How do I know that this particular pod or this particular server or this particular storage area or storage pooled storage is still operating to its optimal thing? How can I improve that? And then, again, dynamic capacity planning. How do I know that, gee, Christmas is coming? How am I going to change my capacity based upon times of the year, based upon what the needs are of services, and looking at that and doing that? So when you look at the modernization story, automation and orchestration are the foundations, but the intelligent data management and what we build out as an industry for structures and solutions will basically enable a lot of the seamless data services in the data center. And we have to focus on what's that higher level where it's not just about the disk, it's about the system. And it's about removing those bottlenecks that exist in the system so that the data can flow freely at the right economic point for that particular service or that particular end user. And by the way, every industry is different. It's just amazing. I'll go into, and I'm in my Super 7 mode and what their latencies are, and I'll go into another customer and they'll say, oh no, we don't need that latency. We're this, and I'm like, okay, and I'll sit there and I'll go, reset, wipe my mental whiteboard, and I have to redraw the whiteboard in my head again about what their requirements are and covering all those requirements and making sure that we have the right solutions. So we do a lot of support standards. So we have worked with Redfish to address all the data center components with the consistent APIs. In general, and it's funny because I go back and forth with the guy that runs SPDK. I'm always like, okay, well, are there parts of that we think should be proprietary? Is it important? And Nate, who runs it, is always driving against me, saying, no, Carol. We need to continue to make this open because we need to continue to work within the open standards and basically enable everybody. And we go back and forth with that. But when I look at this, we do have to have a consistent APIs so that everybody has access to the same information, and we have a somewhat of a level playing field in order to make sure that storage and the ultimate end users benefit from the advances that are made. The other is the unified management of servers and storage with Swordfish. Clearly, we've been a huge supporter of NVMe over NVMe Express, NVM Express, and NVMe over Fabrics. It's funny, NVMe over Fabrics, we have done a huge amount of work in specifying solutions for NVMe over Fabrics and looking at what is the best case latencies and shorten those latencies and provide customers with second source opportunities so that they can do the Lego that they want to do. You don't want to be able, we want to make sure that they have options for disks, for Ethernet, and being able to have that storage over NVMe or Fabrics gives them that flexibility for the latency and the needs that they have for that connection for storage. EDSFF, which is the Enterprise Data Center Storage Form Factor Working Group. That down below, if you look, that's what we've affectionately called a ruler, which is the form factor that basically supports, keep me honest, Intel people, I think 1 petabyte that basically slides into the connector. And we're right now pushing standards for the connector, the backplane, and somewhat of the form factor in order to provide very, very dense storage in a smaller form factor that can be air-cooled. And we're working on that. You tell me.
The petabyte is in a 1U rack ruler.
Thank you.
Is a petabyte.
Okay, thank you, Jim. I know. So that's the 1U form factor on the picture on the top, right? Yeah, okay, just checking. So we've been working hard on that in order to provide scalability through time and being able to service into 2025, 2030, the latencies and the speeds that are really going to be required from all of the industries, including the cloud. So we've been working hard on that. It isn't finalized yet, but the work is, if you want to join, it's there and it's open. So a call to action. I encourage everybody to try out and look into the new hardware and software technologies. You may not be able or want to adopt any of this now, okay? And the economics for your particular needs may not match with the cost or what's available, but at least it will give you a roadmap of what's possible. Particularly in thinking about this new intelligent data management layer and understanding how to knit that all together for a smarter system. I believe that it's really important to understand what are the tools that could be used. If you have questions, lean back on Intel and on your colleagues, on SNIA, on others in the industry to get better ideas on how to maximize performance and maybe minimize cost and be able to develop new solutions for end users. We have a program that we encourage as Intel Storage Builders, and it's really just, it's a consortium of storage companies, and there's a lot of information that gets exchanged through that Storage Builders program. You just heard Jim, so you can always provide feedback to Jim, and he will take it and help out with that. And then just join us in driving data intelligence end-to-end and fueling the future. And being able to look at storage less about my IOPS or my density or whatever, and looking at it more as a system, and looking at it as what are the bottlenecks that I have to go solve, whether it's networking or whether it's compute or whether it's actual that whole end-to-end story, and how I can make it more intelligent. So I think we have about 3 or 4 minutes, so if there's questions.
Yeah, Brooke has microphone, so we're going to get the microphone to you.
Right there.
Wait.
Wait.
Everybody can hear the question.
Including those online.
Thank you. Thank you for the good presentation. You mentioned that fog computing or fog infrastructure in terms of IoT era. So from storage point of view, how do you think, what kind of features do we need to provide to service them well?
So in fog computing for IoT devices, the way I've been thinking about it, and I think it's far from perfect, is there's little bits of data, okay? Everything has a little bit of data. And the way I've looked at it in the past, and I did a report like, I think it was in 2013 when I was looking at the bits of consumer data. I wasn't looking at industrial, but I was looking at consumer. And I believe that every little bit of data forms a story. And we have to figure out classification systems for the data in order to be able to, with the full knowledge of whoever owns the data, to have a data exchange in order to be able to knit that together and find the overall value. And I believe that's how it has to, in a mind map, look, okay? Then we have to build, if we can get that mind map, then build the storage and the software infrastructure and the hardware infrastructure underneath that in order to support the data exchange model, which I believe is basically how we need to mind map it. But it goes to, and the reason why everyone that I found in 2013 was very reticent to agree to this particular idea, and I think it's gaining much more, is the whole thing about privacy, okay? And what's private data and what's public data. And I think there's a way to knit that together so that it's not, we're not crossing those boundaries as much. And so that's the way I've been thinking about it. And I always go sort of, what's the user really want from this? And then I go down, or what's the business want from it, and go down. And that's where I think it has to move to.
Any specific features that storage needed to provide?
I think it depends on the area. As he asked about what are the specific storage needs. Honestly, I think it's going to be huge amounts of storage, okay? Just knowing what I know about, if you think of a car, it's not really an IoT device, but I understand the connected car, and I think this is a similar scale. A huge amount of storage and a huge amount of intelligence on the front end to know exactly what's important and what's not important. And so those algorithms on the front end are going to be very, very important, knowing what you're maximizing for your business. And that's going to be the key. So, but huge, huge storage. And the question, but then I think the other thing, sorry, one more thing. I think what's going to be interesting about it is I think that data is going to go cold very, very quickly, much more quickly than data has ever gone cold, because it's very temporal. And if you're going to resurrect that storage or ever look at that data again, you're going to look at it for additional insights. But that also is a possibility on no-op cycles, on cycles that you have. You might want to go in and look at, okay, what are some significant trends? But you'll be collecting that as it goes forward and basically surfacing it as metadata.
Thank you.
Thank you very much. We are
We're out?
time now.
Okay.
Thank you.
Thanks, Carol.